Hey there, Math 7, and welcome back. It's day 2. It's March 17th, and we're just going to keep going on with this packet. I've had some questions about the link to the packet, so I've posted the link to the front page of my website so that you can access the packet if you haven't gotten it already, or if you don't want to go and pick it up yourself, you have the link. It's on my website. I have also, with caution, posted the answers next to it or underneath it. Use it wisely. Use it academically, not to copy the answers or to do any of those things. Remember, as we move to online learning or the potential for it, it will take your integrity to move on and to learn this stuff on your own here. So we're going to keep going with day 2. We are going to do multiplication with negative integers. We're going to do a couple pages and then we will be done. So the first page, this is the PDF page 7 of the packet, and we're going to go on for, I think, 4 or 5 pages here. You'll recall back to when we did multiplication with integers towards the beginning of the year. We learned all about the sign rules then and how they work and why they are the way they are. Recall that if the two integers have different signs, then the product is negative. If the integers have the same sign, then the answer is positive. So we're just going to go through this. These have different signs, so the answer is negative, and the product. Different signs and the product. Different signs and the product. Anything times 0 is 0. These have the same sign, answer is positive. Same sign, product is positive, so on and so forth. Answer or integers different signs, product is negative. Same signs, same signs. Remember, this isn't about whether you can multiply or not, it's about figuring out the sign of the answer. Some of them have multi-step. You have to work from left to right as according to order of operations. You're going to have negative 2 times negative 6. That's positive 12. Be really careful. When they all have the same sign and there's 3 integers here, our final answer is going to be negative. Watch. Negative 2 times negative 4, that's positive 8. And negative 7 times positive 8 is negative 56. You might start to see a pattern here. Positive times a negative, it's going to be negative. And if they have the same signs, then the answer is positive. Okay, as we start going through some of these, I'm going to start skipping some in the interest of time. And I know you have lots of other subjects to do the exact same things for, so we're going to skip this number 3. We're going to fix Mark's work here on number 4. It says Mark's work to simplify this expression is shown. Explain his error and show how to find the correct product. So you'll see when he multiplied negative 3 times negative 5, he got a negative product, but it isn't. They have the same sign, and the product is positive. So his final answer, even though it's the right integer, it's the wrong answer because it has the wrong sign. Let's keep going. So now we're moving on to adding and subtracting positive and negative fractions and decimals. These are rational numbers. And read these instructions very carefully. I read them incorrectly the first time through. It says to estimate each problem and see if the student's answer is reasonable. If it's not, then we'll need to correct it. Show your work. So I was looking at these, and some of them can be explained without actually doing the problem. So let's look at this. Recall the rules for adding integers, or any numbers. When you add numbers with different signs, you subtract. These numbers have different signs, so we're going to subtract. And we're going to give the sign of the larger number. The larger number here is 6. 6 and 2/3 is bigger than 3 and 1/6. So when we subtract and we give the sign of the bigger number, our answer is going to be positive. Their guess is negative. So their guess is incorrect. I know that our answer is going to be approximately positive and the 3.5. They made a mistake with their signs. So that's what they're asking you to do. They're asking you to estimate and find errors if there are any. Let's try another one. Look at number 3. When we have these two subtraction signs next to each other, this is subtracting negatives or taking away leftward movements on the number line. So we're going to change this to adding the opposite. Adding the opposite. And I'm going to estimate. This is really close to -4. These are both positives now. And this is close to 3. They have different signs, so I'm going to subtract. And my estimate is about 1, -1. So I like their estimate. I think it's pretty close. You keep going. Try that one. Number 4. Oh, remember, you can always pause the video. Pause the video and try this one and see if you can fix or if this answer is reasonable. Pause and come back. Here we go again. Number 5. Let's estimate. 5.9 is close to 6, -7, -10. Oh my gosh, if I have $6 and I take away 7 and I take away 10 again, am I going to have any money left in my bank account? This answer isn't reasonable. I know my answer's got to be negative. This is going to be -1 minus 10. That's -11. Is a closer estimate. Keep going. Keep trying 6 and 7. Let's do number 9. It says, how does estimating an addition or subtraction problem help you to know if an answer is reasonable? Well, estimating is getting a problem where you can use mental math to see if an answer is reasonable. That way, if you go through all this long work and you figure out at the end that you might not be right, your estimate is a really great fallback to see if you're even in the realm of a correct answer. Let's keep going. I've got one last page here, and it's multiplying negative rational numbers. And this, in the packet, there's a page number, and I'm going to go with the printed page number that's on the PDF itself. So I am looking at page 11 in the packet. I'm not going to do all these problems, but I'm going to do a few, and the instructions say to cross off the answers as you go. That's how you'll be able to check your work. Uh-oh, sorry guys. No, you just see my daughter. You'll be able to check your answers on my website. It's listed there. Alright, so let's keep going through this. Find the product of rational numbers. The answers are mixed up at the bottom of the page. Cross out the answers as you complete the problems. Product. When you multiply rational numbers, you're going to multiply straight across numerators with numerators and denominators with denominators. And you're going to be asking yourself, can I cross-cancel? You can cross-cancel. It's like reducing before you get your final answer. If you don't cross-cancel, that's okay too. You'll just need to reduce or simplify your answer after you've made the product. So let's start. Anytime you have a whole number, it's always over 1. And I'm going to cross-cancel here because 2 goes into 4 evenly 2 times. And I'll have a 1. Now I can multiply straight across numerators with numerators and denominators with denominators. And our final answer is negative because one of our integers, or one of our rational numbers, is negative. Let's try another one. Same signs on our fractions means our answer is going to be positive. Cross-cancel. 3 goes into 6 evenly 2 times. And now I'll have 2 times 1 and 1 times 5. Pretty straightforward. Let's keep going. Look at number 4. anytime you have a mixed number like this, you're going to want to change this to an improper fraction by multiplying these two and adding these. Multiply the whole number times the denominator and add the numerator. So we've got 2 times 3 is 6, plus 1 is 7/3, and it was negative, so we'll keep that negative. I'm going to change to a dot because I like it better. That one stays the same. Nothing to cross cancel here, so I'm just going to keep multiplying. 7 times 5 is 35. 3 times 4 is 12. You should have all your resources in your math binder. If you need to use a multi-chart, you have one. It's in your binder. Let's keep going. When you have a decimal and a fraction, I suggest that you change them both to the same format. So for this decimal, you could change it to a fraction easily. You could also change this fraction to a decimal. Oh, did I say that wrong? You could change either of these to the other format. I'm going to choose to change this decimal to a fraction. Of course, that's a choice that you can make. But 75 cents is 3/4, so I changed it to a fraction. And then I get to cross cancel all this stuff. 4 goes into 4 evenly one time, and 3 goes into 3 evenly one time. Multiply across, and I've got -1 as my final answer. Let's try one with 2 decimals. Number 11. When you have the product of 2 decimals, you can stack them up and multiply, but make sure that you stack them up so that some place values are aligned. You don't need to align your decimal point, but you do need to show amazing work so that you can keep track of what you're writing. So I'm going to align place values to make sure that I can keep my work nice and aligned. And now I'm just going to use the algorithm that we're all familiar with. Multiply my place values. I'm going to keep my 0 because I think you'll write that 0, so I'm writing it. And then you guys are going to all write these crazy zeros. And then you're going to add. And you're going to get this. And how many times do we need to move the decimal? There's 1, 2, 3. 1, 2, 3. And our final answer is negative because there's 1 negative. Alright, and that is the end of day 2. I think you should be finished with page 11 of the packet by now. Of course, you can work at your own pace, go as fast or slow as you want to. Do whatever you think is right to keep your mind sharp for when we return to our normal curriculum. Stay safe out there, guys, and I will talk to you tomorrow. Bye!